stopped at this point where we were calculating the electric field due to the potential. So we saw a relationship between the electric field and the potential gradient. If potential is given to us, how can we calculate the electric field? So we saw that electric field is a gradient of potential. That is, E is dV over dx, change in potential with respect to the position. That is what is the electric field's relationship with the potential. Second was the negative sign. So significance of the negative sign was that it told us that electric field decreases where the electric field is in the direction where the potential decreases. Regarding the homework, assignment, only Ali has given the homework. Nobody else has given the homework. Please, class, keep on just submitting your homeworks. One more thing, Ali, in equipotential surface, you don't write the theoretical part. When it is saying draw the equipotential surface, you need to draw how the circles, spheres, and look like. Okay, so Ali has given Marwa and Ubaidullah your homework are pending. The previous homeworks of Marwa are also clear. Marwa is also submitting assignments on time. Ubaidullah, you just get up with the syllabus, okay, with the recent assignment. Previous week's assignments, yours are also clear. So that I can discuss the equipotential surface in the next class. See, V is 3x cubed. We have to calculate the electric field at 2x equal to 2 meters. Now, if the potential is 3x cubed, electric field is what? Minus dV over dx. That is 3. Now, x to the power 3. How do we differentiate it? N x to the power n minus 1. So this becomes 9x square, right? So we have the electric field as 9x square Newton per coulomb. At where, when do you have to calculate? Class, open the camera, all of you, please. At x equal to 2 meter, electric field will be 9 into 2 square. That is 36 Newton per meter. Okay? So, let's write it first. Then I'll discuss this with you. I'll discuss the next question with you. Please write it. No, Aisha, we started from this question only. Before this, we were just revising whatever we did in the last class. Okay. Okay, Marwa, no issues today. Completed, all of you?
Ma'am,
Yes, Ubaidullah. Yeah.
in other processes, we should leave that negative sign.
No, you can write. You can put the answer. You can write it as minus. No need to avoid it. It's just that, see, when we are talking about a vector, it has magnitude and direction. But don't ignore this. You should write it. I just missed it by mistake. You should put this negative sign. Otherwise, you'll not get the correct answer.
Yes, ma'am.
Put the negative. I missed it. Done?
Can you explain this to me?
Okay. See, we have the potential. What is electric field? Different negative of differentiation of potential with respect to the position. Now, when you differentiate it, 3 is a constant number. You have x to the power 3. X to the power n becomes nx to the power n minus 1. So 3 is a constant. X cube is 3x, see, n x to the power n minus 1. So 3 into 3 is 9. X3 minus 2 is 2. So 9x squared. So since there's a negative sign, what I forgot to put earlier, it is minus 9x squared. Okay, now it is asking us to calculate. This is electric field. We had the equation of potential. This was potential. Now we have calculated electric field. Now we have to calculate electric field and when x is 2. So x square will become 4. Okay. Done the writing part by all of you.
Yes, ma'am.
The potential difference you have to calculate between A and B is given as 20 volt. Very easy question. This question I have just written to show you that even when you have a finite values, you always need not get V is x cube, x to the power this, x to the power that. No. If you have a finite value, you can directly use this as minus V by D also. In capacitance, we'll use this a lot. Electric field is minus potential difference by the distance. So we have to calculate the electric field. Electric field will be minus 20. What's the distance between A point and B point? 10. So electric field is minus 2 Newton per coulomb. This is a very easy part compared to the rest of the part. So is this clear to all of you?
Oh, ma'am.
See, Ubaid, electric field is negative of potential by the distance. We write now E is minus dV over dx. So this is for infinitesimally small values and very, very small values are given. But you can use this as V by D also. Potential by the distance. That's why I put this question here. This question 3. What's the potential difference given in the question? 20 volt. This one? Is this given?
Yes.
20 volt. Right? Distance between
Yes.
A point and B point is 10 meters. So potential difference by the change in the distance means the displacement, you can say. So potential is 20, distance is 10, and it's minus. So minus by 20 is minus 2 Newton per coulomb. Yes?
Yes, ma'am.
Oh, please write this.
Sure.
Then we'll come to partial derivation, which I told you, that has to be done differently.
So D means very small value.
This dx, dv, this is very small value. This is the distance. You can write anything. Write it as r if you're getting confused. Write this as r, the separation. This b is the small one, dx, dv. Okay?
Yes, ma'am.
Can we move forward? By now, all of you must have written.
Writing.
Write it.
Finished.
Now completed, no? Okay. See, coming to partial differentiation. Partial derivation, if you get any question based on partial differentiation, it will mention you partial derivatives. Basically, we differentiate each and every component separately. Like, if I want to differentiate x component, see, you have minus del v by del x. So what do we do? How is it different from your normal differentiation? When you're differentiating it along the x-axis or the x part, x component, keep your y and z as constants, as if these were not variables. If y and z square were some constants, how would we have differentiated it? Minus sign would have been there, constant term comes out, so this would have been yz square. As it is coming out, this would be like a constant. If you have 3x, like say 3x square, how do you differentiate it? You keep 3 outside and then you differentiate x square over whatever. So minus yz square is a constant for us. Just forget for 1 second that these yz's were variables. Just think that these yz's were constants. So if these were constant, that you only have to differentiate x square. X square will be 2x. So this becomes minus 2xyz square. Tell me class, first part is clear?
Ma'am, why there is minus?
Minus because minus delta v by delta x. You only corrected me where I missed. That minus, the formula one. Okay?
Yes, ma'am. So here also there will be minus in like normal derivative.
There will be the same minus sign. Okay, if I want to differentiate y1, so minus delta v by delta y. Now when we are differentiating y, yes, we'll treat x and z as constant, as if these were not variables, these were constants from the starting. So how will we write? If x and z are constant, so x square and z square will be brought away. Differential of y will be what? Y to the power 1 minus 1, which is 0. Right? Y to the power 1 minus 1, which is 0. So this is only equal to minus x square z square. Confusion about y to the power 0? Or is it clear?
No, ma'am.
Sir, how?
Yeah, Aisha, say. Should I repeat this part? Y part? Aisha?
Yes, ma'am.
See, x square and z square are constant, so they are brought away. Okay, these are constant, they are taken out. What are we left with? Y. When you differentiate dy over dy, what is it? 1. This weight is also 1. Second way is that y to the power 1 is there. Differentiated using the formula. Okay, differentiated using the formula. N x to the power n minus 1. Y to the power 1 minus 1 is 0. Any constant or function to the power 0 is 1. Again, it is 1. Directly also it is dy by dy, which is 1. This way also it is 1. So here multiplied to 1 is this only. Clear? Okay. And Ubaidullah, what about you? You have understood this one?
Yes, ma'am.
Okay. Coming to the Z. See, when we are differentiating Z, now it is predictable when you are differentiating Z. Partial differentiation means partially you are differentiating. You're taking some values as constant, some values as variable in the next one. So here when we are taking del y, del v over del z, you have x and y as constants, and you will be differentiating the term z here. So x square and y square are constant. So minus x square y is taken out. Z square, how do we differentiate it? Yes, class. Z square का differential क्या होगा?
2z.
2z. Very good. So this will be 2z. Yes, Ali. Right. It will be 2z. So we have the value minus 2x square y z. Now class, finally, when I want to write down the full complete electric field, I can write the net. Right now, since I have all the components separately, I'll write 2xyz square I cap minus x square y square j cap minus 2x square yz k cap. Now, when values are given, I can put the value also. Like if this is asked, calculate electric field at 1, 1, 1. Put x as 1, y as 1, z as 1. You will get the electric field as minus 2i cap minus j cap minus 2k cap. You can even further calculate the magnitude also if it is asked. But till here, this is the best question possible from this relationship question. But partial differentiation is still there in your syllabus, so chances are there. So revise this because we cannot leave everything. So minus 2 whole square plus minus 1 whole square plus minus 2 whole square. This way you can calculate the magnitude of anything you can calculate because you know your vectors. Is this clear? How to differentiate it? Ali has understood. Aisha, clear? Okay. Ubaidullah?
I'm not able to understand how that values came.
Which one?
Minus 2i cap minus j cap.
Oh, I am just saying, if just in case there is one part which has given you the values of x, y, z, like x1, y1, z1 here, 1, 1 means what? This is x, this is y, this is z. So you put 1 in place of that. What is minus 2 into 1 into 1 into 1 square? Minus 2, 1. I've written minus 2 I cap. What is minus 1 square into 1 square into j cap? Minus j cap. I have written minus j cap. Got
Yes,
it, Abdullah? Now you've
yes.
understood? We have just written the values of the coordinates. Marwa, what about you? Your understanding?
Yes, ma'am.
Okay. Please write it from here.
Ma'am? Ma'am?
Okay.
That J cap value I'm not able to understand. Minus x square y square.
Minus which one? Which one?
Minus x square y square.
Why have I written like this?
I think it is z square.
What have I written? Yeah, this is z square, right? Y is 1 only. This is z square. Class, please make the correction. This is z square only. Obedullah, you are right. This will be z square. Okay. Just tell me done once all of you have written. Then we start with energy.
Finished.
Okay, class. Now coming to electrostatic potential. So for this, let us more towards a little bit consider about the potential energy from class 11 to take a more study. So see, when we have energies are always function of something. Right. I'll give you an example. When you have positioning changing, like velocity, so you have in your system kinetic energy, right? Kinetic energy is the function of velocity. All right. If you have temperature, so kinetic energy is a function of the temperature. So this is what is meant by kinetic energy. When you have any temperature change or any velocity. So right now we are not concerned with kinetic energy. Let's come to potential energy. When you have forces in your nature, when forces are existing, then you have potential energy. Like you must have heard about the definition of potential energy. Whenever there is change in place, orientation, shape, there is a potential energy that is existing. But apart from that, you have to keep in mind the forces. If two charges are able to exert force on each other, there will be one potential energy between them. Remember it in the simplest form. You feel, okay, two charges are there. Yes, they will have the force between them. Force will give rise to potential energy. All these forces will give rise to potential energy. Basically, when we have the cause of potential energy, it is based upon the electrostatic interaction. The term interaction means nothing but forces. We'll see in questions how this is possible, but just keep it in your mind that forces, if force is there, potential energy will be there. No force in your system, no potential energy in your system. So Potential energy also, when you have understood the whole concept of potential was work done divided by charge. That was the whole point of the potential. Potential energy is the work done as it is. Entire work done gets stored in the form of potential energy. Okay, entire work done gets stored in the form of potential energy. That is what is the potential energy. It's basically the work done. Work done when you are carrying a charge from infinity to a particular point. That is what is your potential energy. When we used to divide the same thing with the charge, we used to get potential. Remember, work done per unit charge. That was the whole formula. So here in potential energy, it's the work done only. Entire work done gets conserved. See why? Why work done? Work done is force into displacement. And potential energy is a function of force. So directly we can say this whole gets stored in the form of potential energy. So you need to focus more on work done. Automatically you will get your answers. All right. So can we move towards how to calculate potential energy between two charges? Yes? No? Any queries? Anything? All are
It is
silent. Yeah,
infinity to a particular point.
yes, infinity to a particular point. Like, see, I'll show you this derivation of between two charges. If still you have any queries regarding the potential energy, just clarify, just ask whatever you are unable to answer or you are unable to understand. Then you can relate it with the top part which I was giving you as an introduction. See, potential energy of a system. First, I am just taking two charges. So at infinity, I have two charges, Q1 and Q2. Now, I have just drawn it in a graphical manner, but the concept is still the same. What am I doing is, first I am bringing Q1 from infinity to this point A. Now at this point A, I have the charge Q1. It is separated from the origin by R1. This is the charge Q1. Now class, tell me, when nothing was there, I have brought Q1 from infinity to this point. Will it have any potential energy or not? What do you think? Yes or no?
Uh, there will
Yeah.
be potential energy.
Yeah, Ubaidullah, what did you say?
There will be potential energy. I think.
Why?
Work done, because there is a work done.
Okay, there is a work done. But will there, now my question is, will there be a work done?
Yes,
Why?
because it has moved from infinity to point A.
So what, there will be a potential? Why work done only? How do you check work done or energy? What did I tell you? Check it from force. Now see, Ubaidullah, when nothing is present, only Q1 is coming. Will Q1 be able to exert any forces?
Mhm.
Yes or no? If only Q1 is there. Okay, come to Coulomb's law. K Q1 Q2 by R square is the formula. You need minimum two charges for force. So there isn't any force in your system. You have the potential. Potential is a property of a single charge. When you are bringing the charge from infinity to this point, the work done in bringing the charge from infinity to the point means work done per unit charge. That is the potential. Potential will definitely be there. But there isn't any force. Why? There isn't any other charge present. If no other charge is present in your system, there won't be any potential energy, no work done. Straight away for the first one, work done will be 0. Is that clear? Ubaidullah,
I'm not able to understand difference between potential and potential energy.
see, potential is work done divided by charge. But for potential energy, you need force. Means minimum two charges. Minimum two charges are required. So here, when I am bringing Q1 from infinity to here, Now there will be potential because work done divided by charge will give me the potential. But there won't be any potential energy. Means this work done cannot be stored in the form of potential energy because there is no force. No force means no potential energy. Now clear, Ubaidullah?
Yes, ma'am.
Now what I'll do when I bring this Q2, let's say there is one more point. Let's say a point B I have taken. So I am bringing this point B to here. Separation between A and B is R1, sorry, 1 and 2 is R12. R12 I'm saying so that it comes in your mind when I say R12 means separation between 1 and 2. R45 means separation between the fourth charge and fifth charge, like this. That's why I've written R12. It's the separation only. So class, now when I'm bringing the second charge, the first charge is already present. Now look, if first charge is already present, they both will be able to exert forces on each other. So the system will have the potential energy. Correct? Now there will be a potential energy. So for potential energy, what did I tell you? Calculate work done. And how do we calculate work done with respect to potential? We've already seen a formula, charge into the potential difference. So see, when I am bringing Q2 from infinity to this point, which is B, the work done, pay attention to this line, work done 2 will be. What will be the work done? Formula of work done is charge into change in potential. Charge is Q2. Change in potential means final potential minus initial potential. Final potential is at B, right? VB minus initial was at infinity. We are bringing the charge from infinity to this B point. This is the difference. Now, infinity will be 0, potential at infinity. Look at potential at B. When we have brought the charge from infinity to this potential was present, which led to the force or the work done. Q1. Q1 was already present. It is its potential that is leading us to the calculation. When you are calculating the potential, it will be K Q1 by R, R12, whatever it is. Right? So what will be the work done to? It will be K Q1 Q2 by R12. So this entire work done gets stored in the form of potential energy. Means work done is stored in the form of potential energy. So what is the potential energy between two charges? K Q1 Q2 divided by R means the separation between the two charges. See what it is? U is the potential. These Q1 and Q2 are the charges. And R is the distance between the charges. Okay, so is it clear? If you have any two charge, how to calculate the energy? K, Q1, Q2 by R. And K is still the same. K is the same, 1 over 4 pi epsilon naught, which is 9 into 10 to the power 9. This is the same. Is it clear for two charges? This is clear. Why Q1 here? Q1 here because potential is due to Q1. Q2 has just come. It just came and the potential is because of Q1. So that's why we are taking the potential at point B is due to this. Any query?
We do electric potential for a point charge here, I think.
No, see, Ubaidullah, okay, I should write this as VA only, then it will be a little clear. See, when we are taking the charge, we are bringing it, right now, when you are bringing it, that time the potential is due to this A, correct? Potential is due to this A only, right?
Yes, ma'am.
So you are calculating KQ1 by R for this. Okay, potential due to this one. we are seeing the potential due to Q1 on Q2. This is basically, I'll write it here. Potential on Q2 due to Q1. Okay, now clear, Ubaidullah?
Yes, ma'am.
Please write this derivation, class. From the derivation, this one is important. From your n number of charges, usually that derivation doesn't come in the exam. This can come, it's shorter one also, and this usually comes in the exam. But due to n charges, that is very complicated and very big, though I'll discuss it with you because it's there in your syllabus. Aisha, you have your exam also, no? When is the date of your exam? Yeah, Aisha, when is your exam?
My first exam is on 29th. Thursday. Next
Okay.
Thursday.
First 3 chapters are coming? You know?
No, first 2 chapters.
First 2. Oh.
Ma'am,
Yeah,
ma'am,
Ubaidullah, say.
I did till partial derivative topic.
Oh, sorry. Yeah. Please write it from here. Aisha, just again a small confirmation. Chapter 1 and chapter 2 are only coming in your exam, no? Current electricity is not coming?
Our teacher said only the first 2 chapters.
First 2 only, no?
Yeah.
Okay.
Ma'am? Ma'am?
Class done.
Here work done is stored in potential energy.
Yeah, work then gets stored in the form of potential energies. Because see, Ubedullah, energies are always conserved in nature. They get transferred from one form to another. Like if kinetic energy is there, it can get converted to potential energy to some energy. All the energies get converted. That's how the conservation of energy is followed in the system. Written? Everybody? Okay. Uh, potential energy for a system of point charges. So look, there are n number of charges. Now this derivation comes lesser in comparison to the above one. So when you're revising the important things, revise the first one. Okay. So there are various charges Q1, Q2, Q3, Q4, Q5 and nth. Now slowly we'll bring first pay attention to first three. Fourth से बहुत easy हो जाएगा because you will be habituated to it. See, when first charge we are bringing, we have already studied work done in bringing the first one is 0 because there is no other charge present. Now, when I get the second one at B point Q2, their separation is also R12. So, when I am bringing the charge Q2 from here, see Q1, Q2, Q3, Q4, when I am bringing the charge from here, work done, I'm writing directly. We have calculated that it is K Q1 Q2 by R12. Till here we have already done. Now I'm introducing the third charge. Let's say this is C point, this is Q3. So this will be R23 and this will be R13. Now why am I writing all of the separation? Because C class, when Q1 and Q2 are already present, Q3 will have the potential influence because of Q2 and Q1, both of it. For Q2, Q1 was already present. For Q3, Q1 and Q2 both are present. So we have to consider both the potentials. See, when we are bringing Q3 from infinity to a point, how will we calculate the work done? Work done 3 will be Q3. Now what's the potential? K Q1 by R13 means potential due to the first one plus K Q2 by R23 potential due to the second one. First tell me, is this line clear to all? This is like the previous one only. It's just that we are introducing one more charge, so it will also have its effect. Is it clear or not? Huh?
Yes, ma'am.
Okay. Now, if I just open this up, this will be K Q1 Q3 by R13 plus Q3 by R23. 3 like this. So 2 charges were there. Now see, 2 charges were already there. If I bring Q4, let me write down directly first. 1 is already present, 2 is already present, 3 is already present. I am bringing the 4th one. Okay, I am bringing the 4th one. So see, let's say, just understand it here. Let's say separation between R14 is some R14. This is R24. This is R34. These values will be given. I am just writing for us to make it clear that which separations we are taking. So see class, when you are writing work done for, there are 3 energies, 3 forces are possible due to 4. So 3 potential energies will be there. With this, with this, with this. With the first one, it will be K. See, general formula is Q1, Q2 by R. So Q1, what is the second charge? Q4 by R14 plus due to these two, Q2 and Q4. K, Q2, Q4 by R24 plus between these two, 3 and 4. K, Q3, Q4 by R3, 4 like this. Even if I'm introducing, let's say 5 charges. Let's see how do we write for the 5 charges. 1 is already there. 1 is already there. 2 is already there. 3 is already there. 4 is already there. Now I have introduced the 5th charge. Already 4 will contribute towards the 5th one. This is, let's say, R15. They will have one potential energy, R25. They will have a potential energy, R35. They'll have potential energy, R45 like this. So see how to write. Work done by the 5th one will be K, Q1, Q5 by R15. I'll have 4 potential energies which are due to the charges which are already existing, right? Plus K, then Q2, Q5 by R25. Then due to these two, 3 and 5. So K, Q3, Q5 by R3, 5. Then these two are there. K, Q4, Q5 by R4, 5 like this. Now 6 are there, 7 are there. Do you get it? How to write this part? Yes, class?
Yes, ma'am.
Everybody? See, now when I want the total work done, I have to add all of these work done 1, then work done 2, then this work done 3, then this work done 4, then this work done 5, right? Total work done will be like this. So see, remember the method. All these work done will be added, and entire work done will be again stored in the form of potential energy. So you remember it like this. K, Q1, Q2 by R. Whichever, the way we have studied, it's just a method to represent it. 1 over 4 pi epsilon naught for K. Summation of I is to 1, j is to 1 till n means Qi ji by Rij. This is just a way to represent it. In statistics, we use it like this. So this is just a way to represent. Don't get confused. The way we have studied, we'll be using it in that manner. How? This means, see, I is equal to 1, j is equal to 1. That will mean Qi, Ji. Sorry, Qi, Qj. Like if I write I as 1, j as 2, it will be K, Q1, Q2 by R12. If I write I as 3 and J as 6, it will be K, Q3, Q6 by R36. Whatever we have studied, it's just a method to represent it. Don't get confused with this part. This is something else or not. It's just summation. Statistics में तो सबने पढ़ा होगा. Class 10 तक तो statistics थी सबके पास, right? In mathematics, you must have had. And those students who already have mathematics, they must be already knowing the statistical part. So is it clear, or are you getting confused with this? Should I explain this? Is it clear?
Clear.
Clear? Okay. Just write it, then we'll write the numericals. Class completed till here, all of you?
Doing.
Okay, just let me know Ubaidullah once done.
Ma'am, that is example.
What, Ubaidullah?
Last one is example.
Last one is a method to represent it, how you will represent, because you have so many work done, but it's just that you should know how to write this one. Is that clear?
This one U is equal to Q1 Q2 by R.
This is a general formula. Q1, Q2 can be any two charges, like here. Q1 can be this, Q2 can be this. Okay?
Yes, ma'am.
Alright, class. See, a very easy question to start with. 2 questions, let us do and complete this topic. So we'll be only left with capacitance. See, general formula I've written here at the corner. So everybody should participate at least and keep your minds active. You have to calculate the potential energy. So potential energy is simply K Q1 Q2 by R. K, Ubaidullah, what's the value of K?
1 by 4 pi epsilon. No, not
What
9 into 10 power 9.
9 into 10 to the power 9. Ali, what should we put for Q1?
2 into 10 to the power minus 6.
2 into 10 to the power minus 6.
Oh, minus 3.
Minus 3. Yes, right. Aisha, Q2? Yes, Aisha. Aisha Arif.
Yes, ma'am. Minus 3 into 10 to the power minus 3.
10 to the power?
Minus 6.
Minus 6. Perfect. See, class, she is right. Minus has to be put. Potential energy is a scalar quantity. So you have to put in the negative sign also. Marwa, what is the value of R? Yes, Marwa, value of R?
It's 3.
It's 3. Yeah, Marwa, can you just be a little louder?
It's 3.
Just 3. See the units? Shouldn't we write something else? Milli is 10 to the power minus 3. Okay, so this gets cancelled. 3 will get cancelled. We will have minus 18. Right, 2 into 9. And 9 minus 6 is 3. 10 to the power 3 joules. Second says, work done to make the system. What did we study till now? Whatever is the potential energy and That is exactly the work done. Same thing. The work done to make the system is still the same, minus 18 into 10 to the power 3 joules. Third part says, decide whether the system is unbounded or bounded. See, unbounded and bounded, how do you check? Let me tell you this. This can come in your exam. When you have potential energy, you will check whether it's positive or it's negative. If it is positive, if potential energy is positive, it means it is unbounded. Unbounded means unstable. Positive potential energy is not good for the system. Negative potential energy means it is bounded. Bounded means it's a stable system. That is the potential energy, because negative shows attraction between two quantities, and potential energy is all about the attractive forces, conservative interactions. That's why negative potential energy. So is the system bounded or unbounded? Yeah, tell me. Is the system bounded or unbounded?
Bounded.
Bound, because it is negative. Yeah. Last part says work done to break the system. It is saying if bounded, then calculate the work done to break the system. Very easy. Work done to break the system means you have made the system. Q1 you are bringing, Q2 you are bringing, Q3 and all. If you are reversing this process, so it's very easy. Work done, whatever is the work done to make the system is negative of work done to break the system. So it will be minus of minus 18 into 10 to the power 3, which is equal to 18 plus 18 into 10 to the power 3. This part is easy. Clear to everyone?
Yes, ma'am. Second one, I'm not able to.
Second one, work done to make the system.
Yes, ma'am.
Work done, what did we study? If you remember, we have written no, work done is equal to the potential energy. So potential energy is equal to work done. Both are equal. So if I've got U, work done will be equal to U only. Okay?
Yes, ma'am.
Last one. Okay, work done to break the system means whatever energy was required to bring each and every charge, you are making your system. What we have studied. Work done to break it means you are reversing it, bringing the charges back to infinity. So easier, instead of calculating this, it's best you take negative of work done to make the system. Make the system means Q1, Q2 you are bringing from infinity. Breaking means you are sending them back, Q1, Q2 and all back to infinity. So work done to break the system is negative of work done to make. Work done to make the system was this, minus 18 into 10 to the power 3. So negative of this will be plus 18. Right. Everybody has completed? Others apart from Aisha, are you people still writing?
Yes, ma'am.
Okay. You tell me done. Okay. All right then, Aisha. Then I'll not go forward. This question is left. One question from this topic, and then I'll start with capacitance. So this I'll do the next week. Aisha, you just stay. Okay. Rest of you can leave. I just want to discuss your test. The rest of you, this question I'll continue it on when we have the class Tuesday directly. Na? Okay, class then. On Tuesday, let's meet. But class we have to have extra classes now. At least 3 classes per week is required so that your syllabus accelerates. Current electricity is not a very big chapter. But if we get a good practice of the circuits and everything, it will give you good confidence also for solving any questions of circuits. So I really wish if we can have the classes 3 days per week. So your syllabus will also go very fast because after capacitance, then we'll have current electricity. Then at least I want current electricity to go fast so that we can come to magnetism unit. So I'll just get your schedule whenever you all are free and do not have classes. And I'll discuss it with you on Tuesday. So rest of you can leave now. Aisha, okay, class, thank you, rest of you. Aisha, you have the test on 29th, so it means Thursday. So we'll just have one class Tuesday. So in one class, capacitance will not be completed. Then,
I don't understand the circuits.
I'm
Is
sorry,
the-
Aisha.
The circuits like series and parallel.
Yeah, you have
Like
trouble
the
with it?
questions. Yeah, the questions.
Okay, Aisha. So we need one class extra. When can we have this extra class, Aisha? Are you available on Monday?
Yes, ma'am.
Let me tell you a time. Because Saturday and Sunday, the classes with it. See, your 11th class, I'll have the class. Monday we don't have class together, no? So after 9:30 IST, same timing of this batch. 9:30
Yeah.
IST are the classes with you. Are you there, free?
Yeah.
Okay, so 1 hour, 1.5 hour, I'll just brush you up with the series and parallel combination. Okay. And one class of Tuesday we'll get where you will get the concept about the capacitance, basic formula and everything. I'll try to complete parallel plate capacity also. That will be done in the class itself. 9:30, I'll take your class on Monday. Just please have this vacant, Aisha. I'll prepare you for the test.